Hello, everybody, and welcome back. We're going to go ahead and get started here. I hope you guys had a great break. We had a pretty good break. Um, Ready to get started, ready to get going. Today is Tuesday, January 5th. It's a B day. So we are starting on a B day this semester, which is kind of neat. And then we'll have A day tomorrow, the 6th. Um, so this video is our day one for the second semester. We're in the third quarter. Today's notes are going to be over chemical bonding, and it's just going to be kind of a quick little review of some of the things that we mentioned last year to kind of get us back up to speed with some of the basic stuff that we need to kind of understand as we go forward. So welcome back. Here's our warm up. So I'll go over this in class. So I'm not going to go over it in this video. I'm going to go ahead and just say what the answers are so that if you're absent, you can get the answers. So metals are found blank. All right. And so if you look at this chart, you can see that the metals are in kind of a pink color, according to this legend here. And the non-metals are in this blue color. So notice that the metals are in the pink and they are below the stair step and to the left. So our answer here is B. Below and to the left of the stair step. Here's our metals. And that's very important going forward because we're going to be talking about making compounds. And compounds, what kind of compound forms depends on whether a metal is involved or not. All right, so some compounds are formed with a metal and a non-metal. So the first thing we have to be able to do is to look at the periodic table and determine, here's an element. Here's arsenic. Is it a metal or a non-metal? Well, it's in this blue area, so it would be a non-metal. So we have to be able to look at the periodic table and determine whether it is a metal or not, and then go from there. And we'll build on this. Okay. Okay, number 2, carbon is a what? Well, let's go back. Carbon is right here, and it's in that blue area. So again, it's a nonmetal. So carbon is a nonmetal. Okay, and let's look at the question here. So carbon would be a nonmetal. Lithium, Li, atomic number 3. Let's look at that one. If I look at lithium here on the periodic table, it's right there. So that would be a metal. It's in the pink area. Pink area is metals. It's a metal. So lithium is a metal. So there's lithium. What is a chemical compound? It's a pure substance. Meaning that it only has, it's very consistent, so it's pure. You can't separate it by physical means. Okay? And so it's a pure substance that can't be separated. And it's made out of 2 or more atoms. So if I take 2 atoms together, if I take atom A and atom B, atom together, I get a compound called AB. This compound is sometimes referred to a molecule, but it depends on what A and B are, if they're both metals or nonmetals and whatnot. So sometimes we'll call that a molecule, but we can certainly call it a compound, right? And it's a bond that's formed between A and B. They are now glued together. There's a chemical bond between them, holding them together. Isn't that romantic? What is the difference between an atom and an ion? An ion has a charge. So if you take an atom, let's say atom A, this atom starts with A, I guess. Let's take this atom, and let's say it's got an electron on the outside here. Let's take and remove that electron. It's going to become charged. It's going to be A with a +1 charge because it's lost an electron. Or let's say we have atom A over here, and he picks up an extra electron. Now he's got more than what he had before when he was a neutral atom, and so now he's going to be atom with a -1 charge. So either way, it's charged, right? It's a charged atom, so that's what an ion is. And the process of ionization is the process of making an ion. Okay. All right. So that's our 5 questions for our warm-up. This is our plan for the semester. So this is the third quarter. Remember, this year we're in quarters. The first semester is quarter 1 and 2. The second semester, spring semester, is going to be the third and fourth quarters. So this third quarter will start now, and we will go through the middle of March until spring break. And then right before the last day before spring break will be the end of this grading cycle. Then we'll go on spring break, and we'll have spring intersession, I think, the following week, and then we'll have our second quarter. So during January, we will be doing learning about bonding and naming chemical compounds. So we're going to talk about how to determine the name for this guy. What would his name be? Or if I told you, here's a compound, nitrogen monoxide. What is its formula? Right? And the answer would be NO. So how did we go from the name and the formula back and forth? All right, so that's kind of interesting. Not too hard. Couple little things we got to talk about in there. We've got to talk about covalent compounds, ionic compounds, and acids and bases. So a couple things. It gets a little tricky kind of near the end of the unit. As every unit in chemistry, it starts off very simple, and then you kind of start putting the pieces together, and it kind of gets a little bit complicated, a little bit complex, but we'll be fine. In February, we'll be doing Unit 6 on chemical bonding. So we'll talk about ionic and covalent bonding in detail. And the main thing that we're going to learn in this unit is Lewis dot diagrams. So Lewis dot diagrams are going to look like this. Like if you had a carbon molecule with carbon and hydrogen, like how do you draw this kind of structure that represents the arrangement of atoms and identity of the atoms, and like which one's bonded to which, and that kind of thing. So we're going to learn how to draw these diagrams from just the name. So this would be C3H8, and that would be the Lewis dot diagram. So how do we draw that? What are the rules for determining that that drawing? And then what this drawing represents is a three-dimensional structure. Then we can go from there and predict the three-dimensional structure. Right? If you were to make this molecule and look at it, what does it look like? We can predict that just by knowing some simple rules. That's pretty powerful. Unit 7 is on the mole, which I know you guys may be thinking about the animal. It's not the animal. It's a unit in chemistry, and it's used for counting. So this is all going to be about counting atoms. So it's kind of a mathematical chapter. And then in March, we're going to be doing Unit 8 on balancing chemical equations. Okay, and then we're going to take what we learned from Unit 7 and Unit 8, and we're going to put it together into some kind of special advanced chemistry called stoichiometry, and we'll do stoichiometry kind of towards the end of the year. All right, so in April, we will be doing reaction stoichiometry, which is a combination of the mole plus balancing equations. And it's basically counting the reactions. So if I had a reaction like this, H2 plus O2, this forms 2 moles of water. So this is hydrogen gas here. This is oxygen gas here. This is water. So if I started with 1 gram of H2, I had 1 gram of that. According to this balanced equation, how much water can we make? How much oxygen would I need? And questions like that. And then in May, we're going to just kind of bounce around a couple of topics. We're going to talk about gases pretty quickly. We're going to talk about solutions. We might get to acids and bases and energy, but I'm not sure because there's only a month there. So that's 3 units. So we'll just cover what we can with that. And I usually end the year off on acids and bases. So we'll end somewhere either here or here. But if you guys want to talk about energy, just let me know, and we can talk about energy instead. Okay, so that's kind of our plan. This week's assignment. So today is day 1. I do need you guys to complete the warm-up. It's posted on Canvas. If for some reason you can't log into Canvas or you're having issues, I could have you do it through a Google form, and I've already made the Google form just for that purpose, but I'd like you guys to complete it on Canvas. All right, so make sure that you're logging in during class, at the beginning of class, to get the answers to the warm-up, okay? I may not cover the warm-up in the in the videos that I'm going to post. I'd like to do the warm-up together during class at the beginning of class and then get into the video that will cover our content for that day. And then I have an Edpuzzle that I need you guys to do, which is this video, and I've got some questions there. And it's pretty short, so please complete that. Please get started on the right foot. You guys have had a long break. Let's try to get started. Try to get things rolling. We're still going to keep it easy, but I do expect you guys to complete some level of work. Day 2, we're going to do another warm-up. We're going to start talking about naming ionic compounds. We're going to do another Edpuzzle. This is not that big of a topic, so this shouldn't be that long of an Edpuzzle. And then we're going to do some classwork with naming ionic compounds. We're going to practice naming ionic compounds. Okay. All right, today's learning objective. Oh, I didn't finish this. We want to be able to define, or maybe I did. Let me see. No, I didn't. Oops. Okay. So we want to be able to define what a covalent, ionic, and metallic bonding, what those things are. So what is covalent bonding? What is ionic bonding? What is metallic bonding? We want to know the difference between a metal and a nonmetal. We want to talk about what is happening with the electrons. All right, we want to be able to explain it. And an ionic bond, what are the electrons doing? So what are the electrons doing? So we'll talk a lot about that. We'll talk about stability. Why do we have bonding at all? Why do atoms bond together to form compounds? All right, a lot of good learning objectives. The main topic for today is bonding, ionic and covalent. And I'll mention metallic just because we have to mention it, but we're not going to talk about metallic that much. Mostly covalent and ionic. And then when we get into naming compounds, we'll be able to name covalent and ionic compounds. Okay. First, we have to talk about what those things are. All right, so chemical bonding. Our next unit is Unit 5, called Naming Compounds, or Chemical Nomenclature. How do you name or write the formula for compounds? So what we're going to do first is we're going to review what a compound is and how chemical bonds are formed between atoms. And then once we're familiar with the types of bonds that can form between atoms, then we'll talk about how to name compounds. All right. What is a chemical bond? What is chemical bonding? Chemical bonding occurs when two atoms react together to form a new substance. So you take A, you take B, you combine them into a molecule AB. Now again, sometimes we can call it a molecule, sometimes we can't, but it will form a covalent bond. So to form a bond, all right. So what happens in a chemical bond is these atoms are going to transfer or share electrons. One of the two. They're either going to exchange electrons, electrons will be transferred from one atom to the other, or they will share electrons between them, donating their own electrons to share so that those electrons are shared between those two atoms in order to maintain a bond and to make the atom more stable. All right, so this bond and this process of making a chemical bond is a chemical change. Obviously, we're making a new chemical substance. And then atoms are going to react to form new substances that are more stable. So this is why bonding occurs at all. This is one of the questions on the Edpuzzle. Atoms are going to react to form new substances that are more stable because they're going to have full outer shells. And so when you have electrons transferred or electrons shared, this is meant to fulfill the octet rule. The octet rule, or rule of 8, which is what oct means, right? Like an octagon. The octet rule says that electrons like to have 8 electrons in their outer shell. All right, and that says rule there. I know it's hard to read. I didn't write that very good. So the octet rule, or rule of 8, says that electrons like to have 8 electrons in their outer shell. Remember that first shell can hold 2, and then once it has 2 in that first shell, it's happy, it's full. So then we go to the second shell and we put 8. And so the octet rule governs a lot of chemistry, and it just says that atoms are going to react and try to fill that outer shell and try to get 8 electrons in there. Sometimes they're going to give electrons, and sometimes they're going to take them. Sometimes they're going to transfer electrons, sometimes they're going to share them. Okay. What is a compound? We should know this. This was from Unit 2 back at the beginning of last semester. It's been a while. But a compound is when two atoms bond together. Take A, take B, add them together, you get a chemical bond, you get a chemical compound. It is a pure substance made out of two or more atoms that are chemically bonded together, meaning that you will not be able to separate them physically. Okay? You can separate them chemically, but it's difficult. So they're difficult to separate. That's why we call it a pure substance. It's not a mixture. Okay? For example, water is a compound made out of oxygen and hydrogen. These are two elements, hydrogen. So you take two hydrogens, you take one oxygen, you put them together, you get H2O. So you take two hydrogens, you take one oxygen, you put them together, and you get this molecule. And this is actually the shape of water. And so we can draw the Lewis structure for water. It would look something like this. And we'll talk more about what these dots are and how we get this structure later. But so we're talking about bonding. And so this bonding and a lot of these concepts kind of will help us determine what the structure is. And then that structure tells us and explains a lot about water's behavior. Water's got some interesting behavior. Okay. All right, what are the kinds of bonds? There's an ionic, there's covalent, and there's metallic. These are the main three kinds of bonds. I believe there's other kinds of bonds that have been discovered, but these are the three that we mainly talk about. And it's really mainly these two. Ionic and covalent are kind of different kinds of bonds that form, and they're kind of opposites. And the metallic is just another one that's not as common. So that's the three: ionic, covalent, and metallic. All right, so what is an ionic bond? An ionic bond is formed between a metal and a non-metal. So this is the main thing I need you guys to get out of this review, is that if you're going to make an ionic bond and you're going to name an ionic compound, you got to know that it's got to be a metal and a non-metal, like sodium chloride. So that is an ionic compound. And that's because sodium is a metal and chlorine is a non-metal. All right, and we'll talk about how to name that in the next unit. And that's what we're kind of working towards. So you take a metal and a non-metal, you make a bond between them. Electrons will be transferred from one atom to the other. Okay, so one atom will take extra electrons. It'll transfer it from that other atom. So one atom will lose electrons, one atom will gain electrons. Since we're talking about electrons being transferred, these two atoms are both going to be charged atoms. What do we call a charged atom? We call it an ion, and that's why we call this an ionic compound, and that's why we call it ionic bonding. Because one atom will become a positive charge. That's the metal. The metal will become positively charged. And then nonmetals will become negatively charged. Okay, so the metal is going to lose an electron. So here's my metal. It's going to give an electron to the nonmetal. That nonmetal is going to take it. These two charged atoms are now attracted to each other by electrostatic attraction. Opposite charges attract, kind of like a magnet, how north and south poles of a magnet are going to be attracted to each other, or how objects on Earth are attracted to the Earth, right? There's gravity that pulls those objects down, like you, right? You're held onto the Earth by its gravity. These two objects are going to have a charge. So like if I had sodium chloride, sodium has a positive 1 charge, so it's going to be +1, and then chlorine has a -1 charge. And since those are opposites, there's going to be a bond there that's going to kind of hold those two things together. And so these two atoms will stick together and form a bond and form a compound. So that's an ionic bond. And we'll talk a lot more about ionic bonds in Unit 8. Not Unit 8. What unit is it? Maybe Unit 6. Unit 6. All right, so that's ionic bonding. Here's a picture here. So sodium, if you look on the periodic table, sodium is atomic number 11. So let's count out his electrons. He's got 2 in the first shell. There's 2. And then he's got 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. So that's 2 and then 8. And then notice he's just got 1 electron in that last shell. So sodium is a metal, and he's got 1 electron in his outer shell. So what is he going to do? He's going to give it up. He's going to say, I've got 1 electron in my outer shell. I don't want it. It'd be very nice and very convenient if another element could come and take this electron. Because if this electron's gone, now I'm going to have 8 electrons in my outer shell. And I want 8. So I want to lose that electron. So please, somebody come by and get my electron. I don't want it. And so that's what he's going to do. All right, and then chlorine is going to be the nonmetal in this case. Chlorine, like all nonmetals, is going to want to gain electrons. Chlorine has 2 in his first shell, 8 in its second shell, and then he's got 7 in that third shell. Since 7 is very close to 8, he's very close to filling his outer shell. All he needs to do is pull an electron from another element. It's lucky we have this nice sodium here who wants to lose an electron because we're going to take it. So we're going to take that electron, and now what's going to happen? We're going to have 8 in our outer shell. And look at sodium. After this bond forms, 8 in its outer shell. Sodium will now be +1. Chlorine will now be -1. And there's going to be a bond formed between us. Ain't that nice? So now we both have full outer shells. Yeah, we're charged now. So what? So now we made a chemical bond. We call it an ionic bond. And then we call it an ionic compound that's formed between these 2 atoms. And then a compound can form between more than 2 atoms. We'll first kind of start talking about it between 2 atoms, but it can actually be formed by 3 or 4 or 5 or 6 atoms. So by more atoms. So what happens during an ionic bond? In an ionic bond, electrons are transferred from one atom to another. Metal loses an electron, becomes positive. Non-metal gains electrons to become negative. And these 2 charged atoms are now attracted to each other. And that's what keeps it together. All right, and then some of these compounds can be put in water, and they'll actually split pretty easily. So this is why salt, sodium chloride, NaCl, you put salt in water and it breaks up. All right, and that's because of the charge and the reactions between these charged ions and the water molecule. And we'll talk a lot more about that in Unit 8. Okay, so that's ionic bonding, a metal and a nonmetal. Very important. Covalent bonds and covalent compounds are formed between 2 nonmetals. So 2 nonmetals. Both atoms must be a nonmetal. And then electrons are shared between these 2 atoms for mutual benefit. The atoms do not become ions and they have no charge. So they're staying neutral atoms this time, and electrons are going to be shared between them. Excuse me. When these 2 nonmetals share electrons, they both work towards filling their outer shell. And so if you have 2 elements, let's say like chlorine, remember how we talked about how chlorine has 7 electrons in its outer shell? So let's draw a picture. So there's 7 dots around him, 7 electrons. And then check it out. Here's this chlorine with 7 dots around him. So what's going to happen is each of these chlorines is going to be willing to donate its 1 electron. See these 2 electrons? Let me put them in red. So these 2 electrons in red are going to be donated to the bond, and we're going to form a bond here. And so we can even draw the bond like this, right? With that line connecting them. So that's showing a link between the 2 elements, meaning that they're chemically bonded together. And then now we have 6 electrons left over for each of us, because we each took our 7th electron and made a bond. And so now we make a molecule. And this time we can use the word molecule because a molecule is the simplest particle, simplest thing, simplest unit for a covalent compound. All right, and so it's usually nonmetals. So when you have 2 nonmetals bonded together, that makes a molecule, and it's a group, kind of like water. The water molecule looks like this: 2 hydrogens and 1 oxygen. So that's water. So this is a water molecule, covalent compound with a covalent bond between those atoms, and then this is a chlorine molecule with a covalent bond between those chlorine atoms. So electrons are shared, atoms will not be charged, and then the atoms are going to bond together so that they can fill their outer valence shell. So again, this is all about filling that outer shell. If you have two elements that both have 7 electrons in their outer shell, if they share an electron, well then now they both have 8. Okay? Very cool. Let's look at a picture of that. So here's chlorine. He's got 7 electrons in his outer shell. He is not happy, hence the sad face. He has 7 also. This is another chlorine atom. They're twins. He is also not happy with their 7. But if they both share that 1 electron, notice the sharing there. If they both share that electron, well then that electron will spin pretty much equal time between the 2 atoms. It'll essentially be a chlorine. So here's the chlorine and chlorine. Those 2 electrons will essentially circle both elements. Okay, kind of like this in this picture. So they're going to circle both atoms. And so we can write a chlorine-chlorine bond like this, and then we can have our dots. And this is actually the Lewis dot diagram for chlorine. Again, we'll talk about how to draw these diagrams later. But we're all following the octet rule, rule of 8, trying to get 8 electrons in that outer shell. And so remember that this is 2 nonmetals sharing their electrons. Sharing is caring. Let's look at some more examples. Here is chlorine again. The red electrons belong to this chlorine atom, and then the blue ones belong to this one. Same thing. They both share 2 of their electrons to form a bond between them, and that makes us the chlorine molecule. And then oxygen, for each oxygen atom, there's 6 outer electrons. Right? Look at the red ones. 1, 2, 3, 4, 5, 6. So, and then this one's got 6 as well. And so how does oxygen make molecules? Well, each oxygen has 6 electrons in its outer shell, and it's going to want to share 2 of them so that it can make 8. And so now there's 8 electrons on each of these oxygen atoms. And we call that a double bond, which we'll talk more about that later. But electrons are shared here between 2 nonmetals again. And then nitrogen can even form a triple bond where they're going to share 3 electrons each and form a molecule. So we're sharing electrons here. All right, we are almost done here, guys. Let's just talk about metallic bonding, and we're out. So metallic bonding is formed between 2 metals. Okay, it's not as common, and there's not much that we're going to talk about with metallic bonding. But what it is it results, the metallic bond results from the attraction between positively charged metal ions. Let's say that these are sodium ions, like sodium with a +1, like we've been talking about. So let's say that that's what each of these pluses symbols are. Each of those is a sodium atom with a +1 charge. And then these pink things are electrons. And so what we have here is positively charged metal ions attracted to a sea of electrons. So these metal ions are swimming in all these electrons, and they're attracted to each other. And it kind of just holds itself together into a solid thing. All as one solid object. And so that's kind of the bond that forms there. Is called a metallic bond. But it's between 2 metals, and it's these metal ions swimming in a sea of electrons. Okay, we call these electrons delocalized, meaning that these electrons do not exist on atoms. They are free, so they're not stuck on one atom. You can kind of think of it like a planet. Most planets have their own sun, right? So most planets have a home, and they're orbiting a sun. These are like planets that do not have a solar system. They are just out in space, just roaming around. So these are free, delocalized electrons, and there's a swimming pool full of them, just tons and tons and tons of electrons. And so there's these metal ions that are kind of swimming through this electron soup, and they're just kind of attracted to those electrons, and you form a metallic bond. There's not many metallic bonds out there. I can name a couple. One of them is copper. So pure copper is a pure metal that you can find in the earth that has this kind of bonding. Silver is also one. Gold is another. Platinum is another. So sulfur, let's see. These are the main ones, but it's not that common to have a pure metallic bond. Okay, in summary, all right, what I need you guys to take away from this. Ionic compounds are formed between a metal and a nonmetal, and electrons are transferred. So again, we had sodium, we had chlorine, And one of the electrons on sodium is given to him, and you get a +1, you get a -1. So that's ionic bonding. Covalent bonding is between two nonmetals, and electrons are shared. So think about taking a hydrogen and a hydrogen, each with their own electron, and oxygen with 6. What's going to happen? Well, if they share that hydrogen and that hydrogen, that gives oxygen 8 electrons. Let's count our electrons. 1, 2 from each of the hydrogens. And remember, oxygen has his own 6. So 2 plus 6 gives us 8, which gives us happy face. Right? And so the water molecule is happy. So that's a water molecule, H2O. And 2 nonmetals forming a compound where electrons are shared. Okay? So very good, very good. Metallic compounds form between 2 metal atoms. That's really all we need to know with them. Remember, it's a sea of electrons. So you've got these metals that have a charge, and there's these electrons just swimming around. And so they're attracted to those electrons. Okay, and so it just makes a big metallic solid structure with that kind of bonding. Okay. Remember this week's assignments. Day 1 is the warm-up. Make sure you completed the warm-up. Make sure you completed the Edpuzzle. I wanted our first day back to be kind of easy. So this shouldn't be too bad. This shouldn't take you longer than 30 minutes at most. Most of you guys will probably get it done in 10 minutes, maybe 20. And then on day 2, we'll have a warm-up. We'll have another Edpuzzle and some classwork that we're going to do. All right, guys, I'm out. This is Mr. E. Y'all have a great one.